Next, so you see the next topic is laws of thermodynamics. So as a mechanical, this is very basic. And further, if you talk about the HVC engineer, especially for design point of view, this laws of thermodynamics is important. In that, especially the second law, because with the second law, only we got the or we can able to decide which system is applicable as per the season. How exactly I'll show you, but let me complete this other laws first, which can be asked in interview. So you see, second law is important for HVC engineer, other laws for interview point of view and for information. So this law will provide you the fundamental principles which will help taking the decisions and in the calculation. So in that first we have zeroth law of thermodynamics. Okay. So zeroth law is very simple. So as per zeroth law, it says that if two systems attain thermal equilibrium, if attain thermal equilibrium with the third system, it means all the system will attain thermal equilibrium with each other. So what is the thermal equilibrium?
Space in temperature.
Yes. Balance state with respect to the temperature, right? That is thermal equilibrium. So this term we can use in HVAC. Just I'll give you the quick idea. For example, consider this is say room 1 and this is say room 2. And in both the rooms, I'm maintaining say comfort condition. For example, in this, I'm going to maintain 76 °F. In this room also, I'm maintaining 76 °F. So what will happen? Will the heat will transfer through this partition? No. Why? Yes, because these two rooms attain thermal equilibrium with respect to this partition. Okay, so this thermal equilibrium term we'll use at the time of load calculation, especially at the time of heat gain through partition, floor and ceiling, in case if both the side is with the same temperature. Now back to the topic. So zeroth law is simple. For example, assume that this body B is physically connected with body A and body A is physically connected with body C. Okay, assume that body B temperature say 500 degrees centigrade, body A say 700 degrees centigrade, and this body say 300 degrees centigrade. So, and you see, there is no physical connection between B and C. Physically, A and B and A and C is connected. So what will happen after some time? First of all, whenever there is a temperature difference, heat will transfer, right? And the direction of that heat transfer we'll discuss in second law. But first of all, everyone aware of this, heat will transfer due to this temperature difference, right? Whenever there is a different temperature, when you connect these two different temperature bodies, the heat will transfer because of this temperature difference, right? So what will happen? The heat from this A will transfer to C. The heat will from A again heat will transfer to the C. After some time, what will happen? The temperature of the three body will be same, na?
Yes.
That is a zeroth law. Okay, so you see, this is not the physical connection. This is a logical connection. So as per zeroth law, if two body attain thermal equilibrium with the third body, it means all these three body will attain thermal equilibrium with each other. That's it. But in the zeroth law, we don't have this direction of the heat transfer that you'll find in the next law. So this term thermal equilibrium we can use at the time of load calculation. Remember this. Next is the first law of thermodynamics. And this is again for interview point of view. So as per first law, heat and work are mutually convertible. Okay. So if you provide heat to a system, you'll get the work, or if you provide the work to a system, you'll get the heat without the loss. But practical is not applicable, not possible, because in actual practice, definitely there are losses. So this first law of thermodynamics is applicable for which cycle online? Any idea?
Carnot cycle.
Very good. Carnot cycle. Okay, because Carnot cycle is a critical cycle. Okay, so you'll find other definition also, just you can read it later. But you see, it's simple. Heat and work are mutually convertible without any losses. So practically is not applicable. This is for Carnot cycle, critically for comparison. You compare with the actual systems. Okay, again, this is for interview point of view. You can go through once. But the very, very important for HPC point of view is the second law. Now, if you talk about the second law, 1 minute, someone trying to correct. So you see, second law is very, very important for a HVAC engineer. And second law is by different scientists. One is a Kelvin-Planck's and second is a Clausius statement. Kelvin-Planck statement is again related to engines. So here we are not bothered about the engines. We bother about the heat thermodynamic side. No? So we'll pick this Clausius statement. Okay, so the scientist classes. So according to the classes statement. You see, it's simple. Or in just, if I make it simple, it's we can consider this as heat always flow from high temperature to low temperature by nature. Or it is not possible for a system which is working in a cycle, which is working in a cycle, to transfer the heat from the low temperature to higher temperature without the aid of an external agency. Means it is not possible for a system to transfer the heat from a low temperature to high temperature without work, or without work done. Or in other words, I can say, by nature, heat will transfer from higher temperature to the lower temperature. You see, it's very simple. But now we'll discuss the importance of this. But let me quickly complete this theory. You see, heat naturally flow from a region of higher temperature to a region of lower temperature without any system or without any work on that particular system. But you see, heat cannot simultaneously flow from a cooler, means a cold body, means a low temperature, to a high temperature or a hotter body. But if you want to do this, then we require a system. You see, first case, hot and cold. When you physically connect, automatically the heat will start transferring from the hot body to the cold body without any additional work or additional system. But now if you want reverse, then how it is possible? With the
You need
system.
a system.
You see, other image will help. This system is required. So with this system, and you see, here is a cold body and hot body, and you see the direction of heat from cold to hot. Okay, so if you want to transfer the heat from a low temperature body or a cold body to a hot body, without the system, it's not possible. Or in other words, without the system, it is possible to transfer the heat from a hot body to cold body. It means by nature, the heat always flow from higher temperature level to the lower temperature level. Now, can you guess this system?
Compressor and condenser.
Yes, exactly. This is a refrigeration system. With the refrigeration system, it is possible to extract the heat from low temperature and reject in the high temperature side. No? Okay, so we'll discuss in today only about this vapor compression cycle. So in short, this system is nothing but the vapor compression cycle, or it can be a vapor compression cycle, or it can be electrolyte cycle, or it can be a refrigeration cycle. Okay, so if you talk about the refrigeration cycle, it can be a different type. So with the refrigeration cycle, it is possible to extract the heat from the low temperature to the high temperature. But now how this second law is important for a HVC engineer. Second law is very simple: transfer of heat from a higher temperature to a lower temperature. So how it is important for a HVC engineer? Okay, here one question for you. In summer, cooling system is required, or wind or heating system is required? What do you think? It's online. In summer, cooling system is required or heating system is required? Summer, cooling system is required or heating system is required?
Summer cooling.
Correct. And in winter?
Heating.
So now the question is on what basis you can conclude this? How you can say in summer cooling system is required?
In summer, outside temperature is more, so heat transfer to the inside is more. So we
Yes.
need to extract the heat from the inside to outside.
So you see, it means with the direction of heat only we can consider cooling system is required, and the direction of heat in summer is what? From outside to inside, because outside temperature is high, inside temperature is low, right? So heat flow from high temperature to low temperature. Then only we can conclude that the cooling system is required in summer. Without the direction of heat, can we consider this cooling or heating system as per the season? No. So it's simple but very, very important. So this is a base for considering the type of system as per the season. Very simple, but at the same time very important for HVC engineer. So I think you got the importance of the second law of thermodynamics online.